Greetings and welcome to Distilled. In the previous video, we had an introduction to lists. So hope you've seen that video. And in that video itself, I told you to switch to Spider. So if you've not done that already, please make sure that you have Spider installed on your system so that we could move ahead to today's video, right? So in today's lecture, we'll be learning how to plot something in Python, right? So remember, whenever you want to plot something, you'll need some data set or some function that you could plot. So let's say if I have to plot, say, a line. So I'll first of all make a graph like this. And let's say I want to plot a line. So I would um, just plot it like this, given that I know the equation of this line or I know the data points that make up this line, right? So in order to plot something, we naturally need to know its data set, like where this plot actually comes from. Okay, so that data set gets stored in lists. Okay, so whatever data you want to give in order to plot something, you will store that in a list. All right, so we'll be learning how to do that today. And the plots are not limited to this kind. Let's say if you want to not plot the line and rather you just want to plot the data points. So let's say I want to plot data points separately, that okay, these are my data points that I have. So if that is the case, that is what we want. So you could do that as well. That is that this kind of a plot where you just have the data points and not a curve joining them is known as a scatter plot. So you could make that kind of a plot as well. Okay. So and not just that, you could do multiple things in Python with this particular plot. So we'll get familiar with plots, and over the next few lectures, we'll try to familiarize with various attributes of the plots and how could we make the best use of it, right? So that is what we are going to do now. So let's firstly learn how to plot and what all is needed in order to plot in Python. So to make a plot in Python, you'll need a library that is known as matplotlib. Now, this is something that you'll have to install. And for that, you just have to go to your shell over here and type the command pip install matplotlib. And that's it. When you press enter, this library will get installed. We'll be using this command quite a lot for various other kinds of libraries. So make sure that you know this command now. In pip install the name of the library, right? So, and that is what gives Python an edge because there are so many inbuilt libraries that performing various complex operations is actually now very simple because you just have to import that library, install that library in your system and perform that operation. So that becomes very simple. So this is just an introduction, but you could explore more libraries further, right? So when I press enter, this library would get installed in my system. Since I already installed matplotlib in my system, so when I execute this command, it actually shows me that requirement is already satisfied because it is already there in my computer. But for you, that would not be the case. You'll have to install this. So there would be some things mentioned over here that has been installed or such, things like that. And once that happens, once you have this IN2 in front of you, that means your library is now installed and you're good to go. Okay. So now, since we have this library, we'll import this. So we'll say import matplotlib.pyplot. And we do not want to keep on typing this again and again as we plot. So in that case, we'll import this as PLT. So this is one thing that we also discussed in the math module video, where we tried to import different functions in the math module as simple variables. So you could do, simple texts, right? So you could do that with almost with any library. So that is very easily possible. So you could do that. So this is very commonly used, import matplotlib.pyplot as PLT. So we'll do that. So once that is done, you are now free to plot anything, right? Now, as I told you before, we'll need data points. So we'll need X data and Y data. So let's say my X data is 1, 2, 3, 4. And let's say my Y data is just twice of this. So it's going to be 2, 4, 6, 8, right? And now I just want to plot these. So I'll say TLT dot plot X comma Y. Now remember, Y is just twice of X. So we'll see a straight line here. Y equals to 2X. And when I execute this, something will get plotted. Now, don't worry about this warning over here. This always comes when this command is executed. But you could just go to the plots tab over here, next to the variable explorer tab. You'll see the plots tab, and you see this plot has been created. And it is a straight line as we had expected, right? We could make this x equal to y square. So this could be 1, 4, 9, and 16. And in order to um, um, clear this space, just like we clear our variable explorer, you either click on cross, which clears multiple plots if they have been generated, or you just uh, click on this icon, which uh, deletes the current plot but saves the other plots. So I'll just press any one of them. Both will do the same thing for now. And let's just execute this. And when I do that, I see some sort of a parabolic curvature. Of course, this is a very weird thing. Like you see this point connected to this by a straight line, then this connected to this by a straight line, and this connected to this, because that is how the plot actually works. So any point, if you provide two data points, so the plot command would just draw a straight line between those two data points, two adjacent data points. So in order to make a more smooth parabola, you either have to uh, reduce the range, and of course, you'll have to provide greater number of data points. So you could maybe start with 1, 1.1, 1.2, and so on. And similarly, you could give data points for y, and that gives you the plot over here, right? So we'll do such examples further on. But yeah, this is just to start with the plot command, right? You could do a lot of other things with this. So for example, right now you see that X goes from 1 to 4, while Y goes from 0 to 16, right? But let's say we do not want that. We want both X and Y to go from 0 to 16, right? So we could do that by just next to PL2, next line to PLT dot plot, we could say PLT dot xlim, and within these square brackets, we could type the limits. So lower limit of x and upper limit of x. Similarly, PLT dot ylim, lower limit of y, upper limit of y. So when we run this, you will see that this has changed from 0 to 16 and 0 to 16 here. And if you see, the plot in the that we had got previously has not yet been deleted. So we would always want to clear the plot area before actually executing that. So now as we have two plots, if I just click on this icon, you'll see that only the first plot got deleted. This one still remained. So if you have multiple plots, in that case. So now I have multiple plots. If I click on this icon, it will remove everything. Okay. So that can be removed, right? Apart from that, you could also give labels to your X and Y axis. So let's say I want the X axis to say X and Y axis to say Y. So I could do that. Okay. So now I have X label and the Y label. All right. I could also plot multiple, generate multiple plots from the same code. So for doing that, we uh, could make another list, let's say Z, which is now just Y equals to X, Z equals to X. So I'll just say 1, 2, 3, and 4. So this is going to be, so a plot of X comma Z is just going to be a straight line, right? And now if I say plt.plot X comma Z and I clear everything, uh, we'll see both of them have been plotted in the same plot. Now, at times we want this, at times we do not. So if we do not want this, we can separate the two plots by this command, plt.show. So what this will do is it will generate a plot for all the plot commands that have been executed before this plt.show. So for example, plt.plot x comma y has been executed before that. So it will create a plot for this. And any plot command that has been given after plt.show will be plotted in a separate figure. So let's just execute this. And now you see we have two separate plots, right? If I, let's say, type the same thing here, so it will actually plot everything in the same plot again, right? And let's say I plot something else. Let's say plt.plot y comma z, for instance. So it will actually plot y comma z here in a different plot and x comma y and x comma z in the same plot, right? So plt.show. And once again, if we want to separate all the three plots, so I could just write plt.show here, type this command, then again a plt.show, and this command again. So that separates three of them, and we have three figures, plot 1, plot 2, and plot 3. Remember, these x limit, y limit, x label, y label, all of them are available only for the figure that has been created before plt.show. So for example, I mentioned that x label should be x and y label should be y. This was before this plt.show. So in this figure, we had all of these. But in the other figures, we did not have all of these. So if you want that, you will have to type all of these commands again under this plot command between these two plt.shows. And again, if you want the same for this, you'll have to type a command for this, right? You could also give a title to your plot because now, as you see, I've generated three plots and I don't know which plot represents what. So I could give a title here by saying plt.title, let's say first plot. And similarly, plt.title second plot and say plt.title third plot. And if I do that, before that, I'll just clear everything from here. If I run that, I'll have the titles here. So now I know that the first plot is for x comma y, the second plot is for x comma z, while the third plot is for y comma z, right? So now we are very clear of how we could plot different things, right? Now, let's say you would have seen multiple plots where just in the same figure you have different curves that have been plotted. which are used to show that, okay, used to represent the same type of data or used to make a comparison between different data points. So to do that, and there is of course a legend which tells you that, okay, a blue line represents a plot for this and a green line represents a plot for this, right? So there is also a legend option that you can use. So I'll just clear uh, these things and I'll just deal with one plot for now. And I'll try to plot uh, three curves on the same plot, x comma y comma z, and x comma z. And I'll give a label for each of these curves, right? So I could write the other command plt dot plot y comma z and plt dot plot x comma z. So now you know that this actually plots all the three in the same figure because we have not separated them by plt dot show. So when we plot them, we get this kind of a figure, right? So now we don't know what is the blue line representing, what is the green line representing, what is the orange curve representing. So to know what these tell us, we could add labels here. So we could say comma label equal to, let's say x comma y, right? Similarly, label equals to y comma z and label equals to x comma z, right? So this actually assigns a label to the plot of x comma y, the plot of y comma z, and the plot of x comma z. And before we implement this, before we execute this, we have to type plt dot legend. So this displays the legend, all right? So let's just do that. And now you see we have the blue color representing x comma y, green color representing x comma z, while orange color representing y comma z. Okay. This could also give you multiple ways, like you could plot multiple things in the same plot, and these could be very useful when you are presenting your data to somebody, or let's say you're trying to publish a paper and you want plots to look aesthetic, or you want to make a comparison of uh, different things in the same plot. So you could use all of this, right? There are other formatting options that you could explore in order to beautify your plot, and you could make really good figures out of this. So in my publication that I did, I used Python plots exactly as it is, and I was able to convert them into figures for my publications. So they actually give very, very good figures, publication worthy figures. So they're actually very cool. So you could do that. All right. Um, so I hope you are now comfortable with the plots, right? How to um, plot multiple things, right? So now let's uh, try to see something else. So apart from this kind of a line plot that you see over here, you could have other plots as well. For example, you could have a scatter plot where instead of the line, you could show a data point or multiple data points. So for that, I would type plt.scatter x comma y. So what this does is this generates data points, and instead of joining them, it just lets them be. So you see these data points here. Okay. And if you want, you could actually include all of them, like the plot, let's say x comma y, and the scatter plot of x comma y would be in the same figure. And that would look something like this, right? So over here, you see the line plot as well as the data points are mentioned. If you want them to be in a different color, you could say color equals to R, which makes them red in color. I'm not sure if that would work. Yes, that did work. So you could actually change the color as well. And you could just make some really beautiful figures for your work, right? And you could analyze the data very easily using this. Okay. So scatter plots can also be seen over here, right? Okay. Now, naturally, if we want to create plots, we would want to generate data first of all. So that is something that you could generate out of your Python code and then plot that data rather than just, typing it all here. You could generate the data and then plot it. So let's do that. So let's say I want to plot a line y equals to x, right? So to do that, I'll first generate my data. So to generate data, I need my X list. So I'll create an X list as an empty list. I would create a Y list as an empty list. And let's say I want to generate 100 data points from 0 to 100, or sorry, 0 to 99. So I'll start with for I in range 100. This gives values of I as 0 to 99. And we would say x dot append I. So in every iteration, x gets one value, right? And let's say now we are trying to plot y equals to 2x. So we would append 2i for y, right? And then that's it. That is all it takes to generate 99 data points for your plot. And now you could see that you see a lot of data points. So these red sort of um, noisy things that you see over here. That's actually a lot of data points. So it's because of that you see a very uh, sort of shaded region here, but that's actually just data points. So I could generate data points far from each other. So I could maybe say start at 0, stop at 100 with a step of, let's say, 5. So this would generate lesser data points. So the scatters would be a lot clearer. So now, as you see, I have generated lesser number of data points and I have this, right? So this could be very easily used in your Python code. And this would be very, very helpful in analyzing a lot of data. Okay, let's just quickly do an example that is more relevant to chemical engineers. So we'll try to um, plot the concentration versus time data for first order kinetics. So you all should be aware, or if you're not, that's also fine. The concentration in a first order, constant volume first order reaction varies as C equals to C naught, which is the initial concentration, e to the power minus kT, where K is the rate constant, right? And now we need an array of time versus concentration, right? So let's say we want to measure the concentration after every second. So first, let's generate a time array. So I'll say T equals to an empty list. This generates a time array or a time list, right? And I'm generating this T. So for I in range, let's say 100. So I'm generating a time for this thing. And I'll say T dot append I. So I have a list of time from 0 to 99, right? Then I need C naught. So I could say some C naught is equal to, let's say, 10. And I'll need a rate constant. So for that, I'll say K is equal to some 0.1. Okay. And now you need to have this, the concentration array. So I'll make an empty C list here. and something needs to be appended to this C. So I'll say C dot append C naught times. Now remember, we are doing exponent over here. So for exponent, we actually need the math module, right? So if you have not seen the math module video, please do see that. So we'll import math module and we will say C naught times math.exp minus k into I. So at this particular value of I or this particular value of time, I'll get the value of C, right? And yeah, that has generated our data. And now we'll plot this. So let's say plt dot plot time, which has to be on the x-axis, comma, C, which has to be on the y-axis, right? And we want the label. So plt dot x label time, plt dot y label concentration, right? And let's just see how the plot comes up. And you see, this is a beautiful exponential decay that we observe in a first order kinetics. So this is really, really cool. And now let's say I want to compare two different reactions, both following first order kinetics, but one of them has a greater rate constant than the other. So in that case, I will measure the concentrations at the same time, right? So I'll say some K1 equals to, let's say, 10, right? But now I need to have two arrays, one for the first reaction with this as the rate constant, and the second for the second reaction with this as the rate constant. And let's say both have the same initial concentration. So I'll make another array which can hold data for the second reaction. So C1, and we'll copy down the same command here. So C1, and over here, it's the second reaction. So K1I, right? And again, we want to compare these two. So we'll plot both of them in the same figure, right? So let's just clear this and let's see what happens. But before that, remember, both are going to be different curve and we need to be able to identify what these curves are. So we'll have to put labels. So I'll label this as reaction 1 and I'll label this as reaction 2, right? And remember plt dot legend. This tells me what curve represents what reaction. And let's just execute that. And we see a very nice thing. For the first reaction, it is slowly decaying, while for the second reaction, it almost instantly decays because the rate constant is 2 orders of magnitude higher than the rate constant of this reaction, right? Let's reduce the rate constant of the second reaction. Let's make it 0.001. Let's see. So now naturally, the second reaction is going to proceed a lot slower than the first reaction. So let's see if that happens. And now you see the first reaction is going like this, but the second reaction is very, very, very slow. So it is almost looking linear because the exponential decay cannot be captured in 100 seconds. But let's say if we in, uh, make these values slightly comparable, let's make it 0.5. So now you'll see first reaction will proceed slightly slower than the second reaction. And that is what you would see here. So you see first reaction is progressing slower, second is faster. If we make the second reaction is 0.05, so this progresses like this. And both of them are exponentially decaying curves. So that actually becomes very, very interesting. So this is an example that would be very useful for chemical engineers, and you could observe similar reactions, zero order reaction, second order reaction, and so on, using this method, right? So that is all for today's video. Hope you all liked it. Please do attempt the self-assessment test for today as well. I have mentioned that in the description. Also, if you have any doubts, please mention in the comment section. Uh, and hope you have a good time learning Python and strengthening your concepts in chemical engineering. Thank you.